Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we are going to answer October-November 2020, paper 441 from Physics EdX Cambridge syllabus for the IGCSE. Now, as usual, we have 9 to 12 questions, mainly 11 questions they bring for the IGCSE syllabus. At least 3 questions about general physics, another 3 questions about electricity, magnetism, and its electrical components like logic gates, LDR, and these stuff. 1 or 2 questions about thermal physics, 1 or 2 questions about waves and light, and 1 question about nuclear physics, or sometimes they mix ideas to each other. Okay, so now after we do this paper, Shabab, we are going to make revise after. Okay, stay online. We are going to make revise. So what are the last thing that we have to do and to study, inshallah? Okay, yalla, let's say Bismillah. Okay, now question number 1 here. What do we have here in this question? The figure shows an ice hockey player, okay, move on ice. He is preparing to hit what a solid disk called puck, okay? The disk, okay, has a mass, okay, of 0.16 kilogram, moving horizontally across the surface of the ice at the speed of what? 15 meters per second. So what they give us here, they give us the mass and they give us the speed. Calculate the magnitude of the momentum of the disk. Now, send me on the chat, what's the formula for the momentum? Momentum equal what? Yes, thank you. You give me the direct answer, Muhammad. Okay, which is m multiplied by v. Thank you, Marwan. So the mass, which is 0.16, multiplied by the velocity or the speed, which is 15, and the answer, it will be 2.4. Now, what's the unit of momentum? You can write the unit of momentum, or you can write the unit of impulse. So you can write kilogram dot meter per second, or you can write Newton dot second, because both of impulse and momentum, they have the same unit. So this was the momentum for this mass, for this puck, okay, to move in this way, okay, and this was the momentum, okay. Any questions so far? Clear? 2 easy marks, right? Now, what they ask next. The hockey player, okay, strikes the disc, okay, with his hockey stick, okay, and move, and the momentum of the disc is changed. The disc gains momentum of 3 kilogram dot meter per second with an angle of 45, okay, to the direction of where the disc travel. So it was moving to the right, okay. Then there's a change of momentum. And the gain of the momentum gained in this direction was the angle of 45 degrees. This is the gain of momentum. So that means the original momentum was 2.4, and there is another momentum, 3, okay, with different angles. So there will be a resultant momentum. Okay, so what they ask here, part I, state, that means you already know the answer. State the magnitude of the impulse exerted on the disk and the direction, okay, of what in the degrees to the impulse from the original direction. Now, the gained momentum is the impulse. The change of momentum is the impulse. So how much is the gained momentum, or how much is the impulse? Because we know that the impulse is equal to what? To the change in momentum. So the answer, it will be 3.0 Newton dot second, okay? And the direction, it will be the same, 45 degrees. So this is the gained momentum, and there's the increased momentum, okay? The change of the momentum. Now, double I. Determine the magnitude of the new momentum of the disk and its direction relative to the original direction of the travel by drawing a scale diagram. I think this is the last year, okay, for you, October, November 2022, and maybe in May, June or October, November 2022, it will be the last years that they bring questions about this, because they changed their syllabus and they removed this from the syllabus. Now, we have to draw a scale diagram. Now, as we learned several times how we can draw a scale diagram, we have what? 2 momentum here. A momentum original to the right, and it was 2.4, okay? And a gained momentum, okay, above the horizontal with an angle of 45 degrees, and it was what, 3 Newton. Now, how much is the addition for both of this? Now we have to put a scale, okay? Now my scale, okay, I can put a scale, for example, each 1 centimeter is half what, kilogram dot meter per second. So that means what, the 2.4, I would draw it as what, as 4.8 centimeter, and the 3 Newton dot second, the momentum, I would draw it as what, 6 what, centimeter, and I would draw it with a scale, okay? So I want from you to bring your math set, okay, and try to draw as this, okay? I'm going to start from this empty space. I'm going to start from the bottom left. Since I'm going to the right, then I'm going above the right with an angle of 45. I will use my ruler and draw how many centimeters to the right, a horizontal line, the what, 4.8 centimeter, which we know it's the 2.4 Newton dot second. After I draw the first what, the first momentum, I will draw the second momentum. I will continue this line from dashed line, okay, and measure an angle of how much, 45 degrees. Then what, I will draw the second momentum, which is how many centimeter I will draw it, 6 what, 6 centimeter with an angle of 45 degrees, and this 6 centimeter actually represent the 3 Newton dot second momentum, the gained momentum. Now, after I draw these two drawings, okay, I know that my answer is the resultant, and we know that the resultant, it's from the where I started, okay, to where I finish. Draw this line. This is the resultant, okay, and try to measure it and give me how much is the length of it, and after that, how much is the angle of it to the horizontal, because to the original position. So they ask about the magnitude and the direction, okay, from the new, okay, of the new momentum to the original direction. Yes, how much was it? Thank you. Now, Muhammad, give me the answer, which is 10 centimeter, yes? So 10 divided by 2, it will be 5 Newton dot second, right? Okay, who can give me another answer? There is a range of the accepted answer. Yes, thank you, Laith. It's 10 centimeters. So the resultant here, it's what, 10 centimeter, which means it's divided by 2. It will be, according to the scale, it will be 5.0 Newton dot second. There's range. Maybe it will be plus or minus 1 or 2 significant figure. Marwan get it 10.1 centimeter. That means it will be 5.1 or 5.05 Newton dot. Yes. Another answer, 9.8. Yes. Also this accepted. 9.8 centimeter divided by 2. That means 4.9 Newton dot second. So thank you. Most of you get the same answer, which is approximately 5 in Newton or 5.1 in Newton. Okay, Newton dot second. This is what, this is the magnitude of the impulse. Okay, the final momentum, both momentum. Okay, now what will be the direction, the angle here? Measure the angle by protractor, if you please. Measure the angle. How much is the answer? Send me in the chat. Okay, and if you want to send me the whole drawing by picture private on the WhatsApp, send it to me. Okay, I will see it. How much is the angle here? Yes, thank you. Another answer. 24, it's a good one. A third answer. 25, exactly. You are accurate. So it can be what, 25 what degrees to the what, to the original direction. You are fast by drawing. You are amazing. If you are slow, you will take your time, because it's supposed to be answered in less than what, 4 minutes, because 4 marks. Okay. But don't forget to send me your answer. Okay. Any question? Is it clear? Take screenshot here. 29, I think it's a little bit above the range of your answer. Maybe your drawing is not accurate, or maybe your compass is not exact position. Try to be more accurate. Now you don't know during the exam class. You get you draw it and finish it, and that's it. You don't know if it's correct or not. Okay, but it's good drawing. Okay, actually 29, it's out of the range of the accepted range in the mark scheme, and we don't know that during the exam, right? Okay. Any question? Let's move on to the second question. Yalla. Okay. Okay, one of the answers from, okay. Excellent, TLA. Amazing answer. Bravo. Don't make a dashed line. And don't forget to label. You have to label, okay, with arrows. Look here what I did. I label with an arrow and I put how much is it. Don't make a dashed line. Make it what? Only this one you can make a dashed line. And it's not necessarily even. Okay, make it solid lines, all of them. Okay. 36 degrees, it's a huge out of the range. I don't know why. I think the range it was, let me check from what to what. The range, I think it was from 22, yes, it was from 22 to 28 degrees. 22 to 28 degrees. Okay, let's move on to the next question. Okay, let's move on. 27 is accepted. Thank you, Muhammad. Now, second question. What do we have? A vertical tube contains a liquid. A metal ball, okay, is held at rest, okay, by the thread just above what the surface of the liquid, above the what surface of the liquid. The diameter of what of the tube is much greater than the diameter of the ball. The ball is released and it's accelerated downward uniformly, okay, from for a short period of time. And they throw it from here or they drop it from here until it gets what inside the water. Okay, so it was above the water surface or below, oh, I'm sorry, below the water surface. So they released from here to what to fall down like this. Okay, and they say that describe what happens to the velocity of the ball in the short period of time as it accelerates downward uniformly. So since there was acceleration, that means the speed, what happened to it? Increases. And since they said ask about the velocity, you have to mention that the direction is downwards. And since they said uniformly, that means the velocity increases at steady rate or at constant rate, right? So what I'm going to say, they said downwards, okay? So the velocity increases downwards at steady rate or at constant rate. So there's increase of the velocity, but this velocity increases at steady rate or at constant rate. Why? Because they said that there is acceleration and the acceleration was uniform, was constant. Good. Now, what causes it to fall down? If this is the ball, what causes it to fall down? The weight, the gravitational force. And as it moves inside what the water, that means there will be a water resistance, okay, or liquid resistance that against the motion, okay, liquid resistance, okay. And this liquid resistance, okay, we know that as the speed increases, the liquid resistance increases. And I prefer to write gravitational force or to write weight. Do not write gravity by itself. Gravity by itself sometimes is not accepted, okay. So you have to write weight or gravitational force, okay. So what they ask here, B, the ball reaches terminal velocity, like the parachutist finally reached the terminal velocity. Describe and explain the motion of the ball when it's released until it reached the terminal velocity. Now, what do we have to say? We have to say that there was initial acceleration because there was what? Weight act downwards. But as the speed increases, what happened to the liquid resistance? What happened to the liquid resistance as the speed increases? Send me on the chat. Yes, it increases, yes. So what that means there will be a resultant force from the weight down and the liquid resistance upwards, that this resultant force decreases. So what happened to this acceleration? Does it remain constant or increases or decreases? This acceleration downwards. Send me on the chat. Is this acceleration constant? Remains constant or increases or decreases? Exactly, decreases. Why decreases? Because the resultant force decreases. Until what? Until what it decreases? Until the liquid resistance upwards equal and cancel what? the what? The gravitational force or the weight downwards. So there is no resultant force and no acceleration. That's why it reaches what? Terminal what? Velocity. Okay? So if I want to write that, what I'm going to write? Yes, thank you, Adam. Maybe it didn't reach the ground or the bottom of the liquid container. We don't know. Okay? Yes, thank you. So the ball falls down at uniform acceleration due to its weight, but as the speed increases, the liquid resistance upwards, the liquid resistance upwards increases, making the resultant force on the ball decreases, and also the acceleration decreases until the liquid resistance cancels the weight, making no resultant force and no acceleration. So that's why it keep moving at what? Terminal velocity. Easy? Hard? Do you think that you can get this answer? I am sure. Does density play a role? Yes, of course, because they said metal ball, that means it has a high what density compared to the liquid. We don't know what is the density of the liquid. Okay? So according to the difference of the density, maybe it reach the terminal velocity faster or after a long time. Okay? Next, part C. What do we have? The metal ball has a mass of 2.1 grams. That means I will divide it by 1,000 to be in kilograms. This is the mass. It falls a distance. This is the height, okay, or the distance, okay, between being released to the bottom of the tube. Calculate the gravitational potential energy transfer from the ball as it falls. Okay, so gravitational potential energy lost by the ball or transferred by the ball, it's mgh or mg delta h, okay, and the mass, which is 0.0021 multiplied by 10 multiplied by the height, which is 0.80, and by using calculator, the answer, it will be how much? 0.017 joules. Okay, good. Okay, double I. When the ball reaches the bottom of the tube, the speed was 1.5 meters per second. Calculate the kinetic energy at the bottom. So the final kinetic energy, this was the initial potential energy, the final kinetic energy is equal to half V squared. The initial kinetic energy was 0. It's released from rest, which is half multiplied by the mass. Don't forget to change it from gram to kilogram, multiplied by 1.2 square. And the answer by using calculator, it will be 0.0015 joules. As you can see, the energy here is supposed to convert into kinetic energy, but it doesn't. It's much less. Who can tell me why the gravitational potential energy initial is not equal to the kinetic energy final here? Yes. There's no air resistance. There's liquid resistance. Yes. So look what they ask here. Thank you, Marwan. Explain why the value calculated in CI is different. Most of the energy, most of the gravitational potential energy is dissipated due to the work done against what? The liquid resistance. Okay? So that's why the drag force from the water or the liquid, it's a huge, okay? So that's why most of the energy is dissipated, okay? So most of the GPE is dissipated due to the work done against the liquid resistance. Okay, take a screenshot if you please. Let's move on to the next question. Yes, I remember this question. This question is tricky a little bit. Look, what do we have here? A U-shaped tube, okay, of constant cross-section area contains water of density 1,000 kilogram per cubic meter. Okay. Both sides of the U-tube are open to the atmosphere. That means there's atmosphere pressure here and atmosphere pressure here. That's why both levels are what? Same, are even. Okay. Figure 3.1 shows the water level of the two sides of the tube are what? Are equal. Of the two sides of the tube are equal. What they ask then? What they give us information? They say that the atmospheric pressure is what? 1.00 times 10 to the power of 5 Pascal, 100,000 Pascal. The left side, okay, the left side of the tube now is connected to a gas, okay, supply by using what? A length of rubber tube. This causes the level of the water of the left side of to be dropped by how much? 0.200 meters as shown. So this one dropped by, fall down by how much? 0.200. What about the right side? How much it rises? Send me on the chat. If the left one falls by 0.200 meter, the right side will rise by how much? Yes, thank you, Muhammad. Another answer? Exactly, a third answer. Bravo, 0.200 what? Also meter, because they have the same cross-section area. So now, I'm not going to look here. I'm going to look about the total difference on the heights between the first one and the second one. This is the height that I'm going to use. Okay, what do I mean by this? Now you'll see. A, calculate the pressure of the gas supply, given your answer in 3 significant figures. Now we know that the pressure of the gas, okay, there is a formula for it. Now the pressure of the gas at this point here, the gas supply on the left side, it's supposed to be equal on the right side here. But what the pressure is acting here? We have two pressure, the pressure of the liquid and the pressure of what? Of the atmosphere. The pressure of the atmosphere plus the pressure of this liquid. So that means the pressure of the gas equal the pressure of the atmosphere plus the pressure of what? Of the water. So that means it will be 1 times 10 to the power of 5 plus. Now we know that the density of what? Of the water, okay, it's affected by the pressure. So the pressure equal density times gravity times height. So which is equal 1,000, the density of water, they give it to us, times 10 times the height. How much is the height? This is the height that I'm telling you, is the total height, 0.20 plus 0.20, which is 0.400. 0.400. And by using calculator, it will be 1.04 times 10 to the power of 5 watt Pascal. Okay? Did I answer your question, Muhammad? It's 1.00 times 10 to the power of 5. You can write it 1 or 1.00. Doesn't matter on the calculator. It's the same thing, okay? We add the atmospheric pressure because it acts here on the open side. So we have atmospheric pressure plus liquid pressure or water pressure. And we studied this when we was in the course talking about the manometer, right? This is a manometer. Okay? You are welcome. Next part. Part B, the figure 3.3 shows that the gas supply is now connected to what? A cylinder that contains what? A piston. We have a piston here, okay, and the cylinder, and this is the rubber tube connected to the gas supply to push what? The piston, maybe, let's say. The pressure of the gas moved the piston to the right. It moved the piston to where? To the right, outside, okay? The area of the piston in contact with the gas is how much? 0.025 meter square. Now that means there is a pressure from the gas here, pressure from the gas, and there is a pressure from whom? On the left side, there's pressure from what? From the atmosphere, because it's open to the atmosphere. So that means the difference between the pressures make a force on what? On the piston to move it to where? To the right. Calculate the resultant force on the piston. So we know that pressure or change in pressure equal what? Force or change in force divided by what? Divided by area. So the change of the force or the resultant force is what I'm looking for. So that means the pressure, the force or the resultant force is equal the change of the pressure multiplied by what? By the area. This is the area. So the pressure change is caused by only not the atmospheric pressure, the value of this one, because the pressure from atmosphere right and left is they cancel out what? Each other, right? So what it will be here? That means 1000 multiplied by 10 multiplied by 0.40 or 400 multiplied by what? The area, which is 0.025, and that causes to have 100 Newton force as resultant force, okay? Act on what? On the piston. This is the resultant force act on the piston to the right. Good? Double I. This is the trick here. This is so first trick here, we have to subtract the atmospheric pressure. I'm not talking about the total pressure of the gas. I'm talking only about the difference in the pressure between the left side and the right side, okay? Double I, the pressure of the gas caused the piston to move a distance of ½ meter to the right. Calculate the work done by the gas, not the resultant force, by the gas from the supply to the piston. Now the work, what's the formula for the work? Who can tell me on the chat? What's the formula of the work? Work equal what? Excellent. Another answer, force multiplied by distance. So how can we find the force? Now we are talking about the force of the gas. So the force of the gas, it's equal the pressure of the gas multiplied by the area, okay, that's caused the force, multiplied by the distance. So the pressure of the gas, which is 1.04 times 10 to the power of 5, multiplied by the area, which is 0.025, okay, multiplied by the distance, which is ½ meter. So again, ya shabab, the trick here was to have that this force is the pressure from the gas itself, the total pressure of the gas multiplied by the area. So what we calculate in the first part, multiply by the area that they give it to us. Is there error carried forward in this type of questions? I think that yes, of course, there will be error carried forward in these type of questions, because if there is no error carried forward, how do they ask questions? Because if you do the mistake in the part A, you keep the same mistake. So no, I think you have to show them what are the values that you have, what are the values you use, okay, to give them the answer. So eventually, the work done, it will be 1,300 watt joules. Any question? Don't feel sorry or bad, okay? Because the curve or the boundary keep going lower, and that's good for them, okay? Take screenshot. Let's move on to the next question. Question number 4. Now, a large tested tube contains a liquid at room temperature, okay? An electric heater is immersed in the liquid, okay, and switched on. Thermal energy is supplied to the liquid by the heater. The temperature of the liquid increases until it reaches the boiling point. The liquid then starts to change into gas. A. Describe in terms of molecules and their motion how a liquid different from a gas. Now, they ask about how the liquid different from the gas. You can compare between them, or you can talk about liquid by itself, then talk about gas by itself, or you can talk about both of them together, as we said. Now, last week you did paper, what, 6? 2 days from now, you are going to do paper 4. After 2 or 3 weeks, you are going to do paper 2, inshallah. So don't worry, okay? This exam, it will not be hard, and don't forget that it depends on the curve, how much the student gets, okay? So we need to describe in terms of molecules how the motion, okay, and their motion, how the liquid are different from gas. We can say that liquid molecules, they are what? Liquid molecules are closer and don't move freely. They slide over each other. They slide and, okay, over each other. While gas molecules are further and move freely randomly. Good. Okay, next, part B. Describe what happens to the molecules of the liquid as the temperature began to increase. Now, the molecules, okay, they gain heat as kinetic energy. So what happened to their motion? It becomes faster, right? And they move a little bit what? Farther, right? So that's what happened. They gain heat as kinetic energy to move faster and further from each other. Good. C. Explain in terms of molecules, okay, why a supply of thermal energy is needed to change liquid into gas. Now, why do we need this energy? Why do we need this energy? We need this energy to do work against the molecules to break the bonds between them, right? Thank you, Muhammad. So we need to break the bonds. As we break the bonds, the molecules what? Move away and becomes gas. To do work against the molecules to break bonds. bonds between them. Good. Take screenshot. Next, part C. The density of the liquid in the test tube is 0.86 grams per centimeter cube. The volume of the liquid in the test tube is 50 centimeter cube. The liquid reached boiling point. It now absorbed 18,000 joule of thermal energy, and all of the liquid, okay, it changed from liquid to what? To gas. Calculate the specific latent heat of vaporization of liquid. Now we know that energy, which is this amount, this is the energy, equal mass multiplied by latent heat of vaporization. Now they ask about the latent heat of vaporization. Now we know that the energy is 18,000, but I don't know the mass. So I have to find the mass. So what I need to do? Exactly, I need to measure to find out the mass by using the formula of density. So we know that density equal mass divided by volume. By doing cross multiplication, mass equal density, which is what? 0.86 multiplied by the volume, which is what? 50. And I put this values here. So 0.86 multiplied by 50 divided by this. By using the calculator, I will get how much? 420 joules per what? Grams. If you want to convert it into kilograms, no problem. So you can divide the whole answer by 1,000, then you write joule per kilograms. Good. Any question? Okay, take a screenshot and let's move on to the next part. Okay. Next question number 5. A metal container is used to cook food. The thermal container has a thick wall, okay? Hot cooking oil, okay, at the temperature of 120 degrees Celsius is poured into the container A. The outside surface of the container gets hot, okay? Some of the thermal energy passed through the metal because of the vibration, okay, vibrating of atoms, okay, in the metal collide to the neighbor atoms and transfer energy to them. Now, we know that this is a way of conduction, how the heat transferred by conduction, okay. Explain how the rest of the thermal energy, okay, this says some of the energy, okay, explain how the rest of the thermal energy is conducted through the metal container to the outside of the surface by another process. So we have conduction not only by the vibrating of the atoms and they collide to each other, there is another way to transfer heat through metal surface. Who can tell what other way? By what? Thank you. Another answer on the chat. Through the metal. Through the metal. Through the metal container. Not through the oil. Through the metal container. Through the metal container. Exactly, by conduction. Another way of conduction. Yes, exactly. The electrons. The electrons gain this energy, okay, and they move faster and farther, collide with other electrons and other atoms or molecules which they are farther. They transfer the energy to them, okay. Electrons gain energy to move faster and further, collide with other electrons or with far molecules and transfer heat to them. So you have to be careful here. They ask for the metal container, through the metal container. So I'm not talking through the oil by convection. I'm not talking about the surface by radiation, okay? Okay, good. 3 marks, yes. Next. The outside surface, now surface. Surface, that means radiation. The outer surface of container is brightly polished and shiny, okay? Bright and shiny, okay? Shine bright and like a diamond. Explain how this reduces the power that needs to be supplied to keep the oil at the correct temperature. Explain how this reduces the power that needed to supply, okay, to keep the oil to correct temperature. Exactly. Less heat is transferred by radiation, since this polished bright surface is what pore emitter for heat, right? The surface is pore emitter. So what? So less heat radiation is transferred from it, and less heat is lost by it. Okay, when I'm talking about heat radiation, I'm talking about infrared radiation, right? You remember that. So let's infrared heat radiation. You can write here infrared heat radiation. Good? Clear? Take a screenshot. Next. See what they ask. The metal container, okay, is spherical. It has spherical shape. The spherical container has a smaller surface area, okay, than what the long thin container of the same volume. Explain the advantage of using what spherical container. Now, whenever the spherical we have spherical container, that means it has less surface area. So that means there's less radiation come out from it. So that means less loss of energy. Less surface area. So less infrared radiation and less energy lost. Energy lost from it. Good. Any question? Okay, let's move on. Question number 6. The figure shows a shallow tank viewed from above. The depth of the water is different, okay, in the two parts of the tank. So we have deep region and we have shallow region, and they didn't mention which one is deep and which one is shallow. The figure shows the crests, okay, and the troughs through what the wave as they pass from left to right. So this is a crest, this is another crest, this is another crest, okay, and this is trough and this trough, okay. Now, who can remind me by the 6 S's? Who can remind me? Send me them on the chat. Who can remind me the 6 S's? Huh? In shallow water, yes, what will happen to the speed? Becomes slower. What will happen to the wavelength? Becomes shorter, exactly. What will happen to the angle? What will happen to the angle? Becomes smaller, exactly, thank you. What will happen to the frequency? What happened to the frequency? Stays the same, okay? And what happened to the direction? Exactly, it bent towards the normal, okay? So shallow, slow, short, small, same, towards the normal, okay? Now you can see here that the angle here, 45 degrees, is more than 33 degrees. So that means this is the deep region, and this is what? The shallow region, right? And the wave traveling from where to where? From left to right. Okay, now, what they ask here. As the wave passes from one side to the other, the direction of the wavefront changes, okay? A, explain why the direction of the wavefront changes in the way as shown here. Now, I remember that I told you that if we have 4 people here, 1, 2, 3, 4, there was walking in some region which is fast region, okay, and suddenly from for example from concrete, okay, they will move to where? To the sand, okay, or a roughly area, okay, roughly ground. So that means they move with the same distance, okay, every second. But the one that becomes here, it moves with a slower speed. So it covers what? Less distance during the same time. So these people, they will be what? Faster, or they will be in front of them a little bit. And these people here, they cover what? Less distance during the same time. So that's why it bend or it change what? Direction. So that's how we can get the 3 marks. One of the answers from Marwan, thank you, Marwan. Shallow, shorter. Okay, now I'm not going to write the 6 S's here. Thank you, Marwan. So if we look to the mark scheme about the key points or the marks that they ask about this one, okay, let's check. We are talking about question number 6 here. Okay, look here what they ask, what they said. They said that, look here. Where is it? They said that, okay, look here, speed changes, that's a mark, speed changes, or the wavelength becomes smaller, okay, on the right side, or the waves becomes slower or slows down in shallow water, okay, that's the first mark. Second mark, the wave speed, okay, is smaller on the right side, that means the wave will slow down on the right side, okay, as it hit the boundary. So the part that hit the boundary, the bottom part, which is the boundary, it slows down, okay, and the bottom side of it, okay, it will move less distance. So that's why this section have different what direction. Okay, it's not that clear, the mark scheme, but because it's not for the student, it's for the teacher to put the marks. So what I'm going to say, as the wave, okay, front reaches the boundary, it slows down since it is shallow water or shallow region. So the lower part or the bottom part of this of the wavefront, the bottom part of the wavefront will cover less distance, okay, per second, per 1 second. So it bends and seems to what? To have changed its direction. Good. Write this down. Next, B. The speed of the wave in the left hand of the part of the tank is how much? 0.39 meters per second. This is the speed in the deep region. Okay? Use information from the figure to determine the frequency, how much it is. Now look here to the graph again. What is this distance? The 2.6 centimeter. Who can tell me what this distance, the 2.6 centimeters? Tell me on the chat. Muhammad, give me the answer. What is the answer, ya Muhammad? Bravo. This is half wavelength, since the wavelength is the distance between the crust to another crust. Bravo. So we have to convert it from meter per second. Okay, so we have to convert this centimeter to become meter. So we know that speed equal frequency times what? Wavelength. So that means frequency equals speed over wavelength, which is 0.39 over 0.026 multiplied by 2 to get what? The wavelength. Okay, and we have to convert from centimeter to meter divided by 100. So the answer, it will be 7.5 watt hertz. Good? Clear? Again, what we did here. The wavelength is 2.6 centimeter multiplied by 2 over what? 100 to convert it from what? Again, why we multiply by 2? The wavelength is the distance between crest to another crest, not from crest to trough. From crest to another crest. Okay? So the distance here is twice the distance from crest to trough, which is 2.6. So this is the wavelength, right? Okay, you are welcome. You have to be careful. You will lose a mark if you didn't do that. And also you will lose a mark if you didn't convert from centimeter to meter. And it's only 3 marks. علامة من هون علامة من هون علامة من هون راحت ال A star. No, it's not like this. You need to lose approximately 30 marks, okay, to lose the A star most of the time. So be careful. Do not lose as much as you can. Keep steady, keep focused, and inshallah you will do your best and you get the highest mark that you can, inshallah, and you deserve the best, inshallah. Double I. Determine the speed of the wave, okay, on the right side in the shallow water. So they ask about the speed in the shallow region, how much it is. Now we know that refractive index, okay, I'm not talking about light, but it's still the same thing. Refractive index equals C log V. So speed in the deep region, which is faster, over what? Speed in the shallow region, what they ask about it. But do I know how much is the refractive index? No, thank you, Muhammad. The refractive index, I have to find it out, which is sine I over what? Sine R. Let's go back to the question. What's I here? How much I? Is this I? Is this the angle of incident? Yes, it is the angle between the wave front with what? With the surface. But if they give us the ray here, okay, we have to draw the normal, okay, 90 degrees to the surface. We have to draw the normal. This angle of incident, it also will be what? 45. So the angle of incident, which is 45, and the angle of refraction is 33. So that means it will be equal sine 45 over sine R. And by using calculator, How much is the answer? How much is sine 45 over sine 33? I don't have a calculator. 1.3, thank you. I'll substitute it here, okay? This is the second step, this is the first step. So 1.3 equal the speed in the deep region, 0.39, divided by V, and V, it will be, by doing cross multiplication, it will be how much? 0.30 meters per second. Okay? So 1.3 equals 0.39, the speed in the deep water, divided by the speed in the shallow water, and we will do cross multiplication and we get the answer 0.30 meters per second. Don't forget to write two significant figures, okay? Even if the answer is 0.3, you have to put the 0, okay? Good. Any question? Okay, let's move on. Take a screenshot if you please. Let's move on to what? To question number 7. Question number 7, what do we have? A permanent magnet, okay, is made by one material. Underline the material which is possible to make a permanent magnet. Who can tell which one can be a permanent magnet? Which one of these? Yes, another answer. Thank you, Muhammad. Another answer. Thank you, Sandra. A third answer. Okay, it's a steel. It's obvious. Thank you. It's a steel. Bravo. Part B. An electron source produces a narrow beam of electrons, okay, that travel at the same speed, okay? The electron source is placed in a vacuum and a beam of electrons travel vertically downwards, like this, okay? As shown in the figure, the electron beam before it passed through between north and south poles of magnet. So we have north and south pole. I. Describe what is meant by the direction of the magnetic field and state the direction of the magnetic field between the two poles. What is the direction of the magnetic field here? Describe what is meant by the direction of the magnetic field. Is the direction of what? Excellent. Is the direction of the magnetic force on a north pole magnet. And it's going from where to where? It's going from north to south. Yes. So the direction of magnetic force on north pole of a magnet, and it is from where to where? And it is from north pole to southward. To south. Okay. Good. Any question? Okay, let's move on. Double I. Describe and explain what happens to the beam of electrons in the magnetic field between the poles of the magnet in this figure. Okay, let's go back to the figure. Now we know that these electrons are negatively charged, and as the electrons go through the magnetic poles, they will attract to the north or they will attract to the south. Huh? They will attract to the north or they will attract to the south. Yes, in which direction do they deflect? Yes, tell me. To the south, huh? I will hit you now, Ya Muhammad. Huh? To the north or to the south? In which direction does it change its direction? To the north or to the south? Neither. Charges do not attract to magnet. They are affected to each other. Yes. So I'm going to use what? Fleming's left-hand rule. Because I'm talking about magnetic force here. So the first finger from north to south, the second finger to the charges, okay, downwards. So the direction of the thumb, it's out of the page. But this is for alpha, or this is for positive charges. Beta, electron or beta is negatively charged. So it will be where? Deflect into the page, okay? So the direction, the beam of negative electrons left hand rule. Always the force by left hand rule. Okay? The beam of negative electrons will deflect into the page to the opposite of Fleming's left hand rule. Okay? You have to be careful. I'll talk about Fleming's left hand rule. I also make it clear that I'm talking about negative electrons. That's why it moves in the opposite of Fleming's left hand rule. So you can say right hand rule, okay, because they are what? They are electrons, okay? But it's not accepted in the mark scheme. You have to make sure that you understand it's magnetic force by left hand rule. Okay. Next. C. The beam consists of alpha, beta, and gamma rays. Alpha particles, beta particles, and gamma rays. Okay? Explain how a uniform magnetic field may be used to separate alpha from beta and gamma. Now we know that there will be a magnetic force on the alpha, okay, since it's positive, and on the beta, since it's negative, but they will be in what? In opposite directions. But gamma, since it's in neutral, it keep moving what? In a straight line without being affected, right? So the magnetic field, don't write it like this, okay? The magnetic field do not change the direction of gamma rays since it is neutral. But alpha particles will deflect due to Fleming's left hand rule, while beta particles will deflect to the opposite direction since it is what? Since it is negatively charged. Okay? Good. Okay. Let's move on to next question. Question number 8. A. Explain what is meant by EMF, electromotive force. It's what? Tell me, what are the electromotive force? Is what? Yeah, send me on the chat. The amount of what? Yes, thank you. Of energy supplied for each one column of charge to pass through the whole circuit. Thank you, Muhammad. To pass through the whole circuit. Through the whole circuit. Thank you, Laith. Complete circuit, whole circuit, yes. Yes, thank you. Next. An electric heater contains two heating elements, R1 and R2, with two switches, S2 and S3. An electric motor operates as a fan to blow the cold air over the heater to become hot. Okay, heating element. So we have a switch S1 for the whole circuit. There's a motor here to push the cold air to pass through the heaters, and we have switch S2 and switch S3. The heater, the heater is provided with the main supplied of EMF of how much? 240 volt. Switches S1 and S2 are what? Closed. Okay. Heating element R1 get hot. Okay. And the resistance of R1 is 30 watt ohms. Okay. Calculate the current, in the heating element R1. So I will call it I1. Okay. I1, they ask about it. Now we know that V equal what? IR. So since we are talking about this, they are connected in parallel. So we have the same voltage, which is 240 equal I1 multiplied by 30. So that means I1, the current here, it will be 8 ampere. Okay, 8 ampere. Next, calculate the power produced by the heating element R1. Now we know that power, of 1 is equal voltage square divided by what? R. So V1 over R1. And since they are connected in parallel, they have the same what? Voltage, 240 square divided by what? By the resistance, which is what? 30. And by using the calculator, the answer, it will be 1900 watt. What is this formula? You can say power equal IR, IV, and you can find it out, or this formula. If you want to use this formula, you will get the same answer. So for example, the current is 8 and the power, voltage is 240. I would still get the same answer, and I put it as two significant figures. I would still get the same answer. Okay? You can write it in 2 or 3 significant figures. Yes, of course. Good. Okay, next. The resistance of heating element R2 is what? 60. It's twice what? 30. Be careful, Switches S1 and S2 and S3 are what? Closed. State and explain how the current R2 compared to the current what? R1. Now, which one has more current? I1 or I2? Which one has more current? I1 or I2? The 30 or the 60? Yes, the 30. Yes. Why? Because it has less resistance. So they ask about what? How much is current through R2? It will be what? Exactly half the size. The current through R2 is half through R1. Since what? Since the PD is the same and R2 is twice R1, twice resistance than R1, twice resistance than R1. Okay, good. Okay. Take screenshot if you please. Next. Number 2. The current of the motor is 0.1 ampere. The current of the motor is 0.1 ampere. And the current here, we say that it's 8 ampere. Okay, we find it out. And the current here, it will be 4 ampere, which is half, as they said. Okay. The current of the motor is 0.1 ampere. The cable from the electric heater is plugged, okay, for the main socket. Okay, it is safe when the current is less than how much? 20 ampere. Suggest and explain a suitable fuse rating for this circuit. Now, we have to know that the total current total, as we say that, it's the current through the motor plus current I1 plus current what? I2, which is 0.1, okay, plus 8 plus 4, and the answer, it will be 12.1 ampere. So the fuse supposed to be what? Between what and what? Above 12.1 and less than what? 20. So it can be 15. The fuse, okay, can be, let's say 15, 13, okay? 13 ampere, since it is greater than what? 12.1 ampere and less than 20. Okay? Good. Take screenshot. We finished question number 8. Let's move on to question number 9. What do we have here in this question? 9AI. Describe what is observed by total internal what? Reflection. What's observed by total internal reflection? The light is completely reflected back. The light is completely reflect back to the same what? Medium. To the same medium. Okay. Next. State 2 conditions required for the light to be total internal reflection. We say it many times. Okay. The light incident at an angle okay, let me redraw it. Okay, rewrite it. At an angle greater than the critical angle, greater than the critical angle, okay, and the light incident a boundary from what? Light incident. Let's see, that's a boundary of what? Of higher refractive index to lower refractive index. From higher to lower refractive index. Okay, or you can say from slower to faster region medium. Good. Okay. Take a screenshot if you please. Next, D. Describe and explain, okay, the action of optical fiber in what? In communication technology. You may draw a diagram if you wish. Now, it's not necessary to draw, but yes, we have an optical fiber, okay? So we have a laptop here, a computer, okay? We have an optical fiber from one laptop to another, okay? and the light keep what? Reflecting through a total internal reflection, total internal reflection, total internal reflection, and there will be what? Coding and decoding here. Okay, no problem, no problem, Laith. Okay, so what happens here? What we are going to say? We are going to say that the information or the data, okay, that one computer or the picture or whatever video, okay, of one computer or one sender, okay, is coded to be digital. So that means it's converted to be light or infrared, okay? And this infrared or light pass through the optical fibers, okay, and keep reflecting total internal reflection until it reaches the receiver or the other laptop or the other side. As it reaches the other side, okay, it keep reflecting total internal reflection through the inner side of the optical fiber. It will be decoded, okay, and it return back to from digital to being what? Information, and can be read. Okay, good. Okay, so light. Oh, I'm sorry, not light. Data, okay, are sent as digital light signals as digital light signals to pass through the optical fiber and keeps reflecting total internal reflection, total internal reflection within the fiber until it is decoded to be read or hear, by the receiver. Okay, good. Take screenshot. And let's move on to the last question here, question number 10. Okay, and here in this question, what do we have? A radiation detector is placed on a bench of a laboratory. It detects the background radiation to be 40 counts per minute. This is the background radiation. State what is meant by the background radiation and suggest one source of it. What's the background radiation? It's the radiation that come out from what? From the environment, or it's due to the environment, huh? The radiation due to the surrounding and the environment, due to the environment and the surrounding. Okay, like from the rocks or the sky or from the sun. It's always exists with a small value, okay? A sample contains atoms of radioactive isotope polonium-208 is removed, okay, from a lid container and brought closer to the detector. The average count rate increased to how much? To 890 counts per minutes. So this 890, it's not only from the polonium, it's from the polonium, okay, plus how much? Plus the background radiation. So it's 850 plus 40, okay? Continue. When two sheets of paper, okay, are inserted between the sample of the and the detector, the average count rate will turn back to how much? To the background radiation. That means the paper absorbed this radiation. Okay, polonium is respective to the sample polonium 84208. Okay, it is decay to an isotope to become what? Lead. I. Deduce what type of radiation emits polonium. Explain your answer. What do you think? When we put two sheets of paper and it stopped all this radiation, what we are talking about? Are we talking about alpha or beta or gamma? Thank you, Muhammad. Another answer. Thank you, Sandra. Okay. At least we finished. No. It's two sheets of paper, not many sheets of paper. Okay. Two sheets of paper. They cannot stop beta. Okay. So I'll talk about alpha. Okay. Only alpha particles or alpha, okay, particles, since they are completely absorbed, absorbed by the paper, Next, write down the nuclear equation for this. Okay, now we know that it's alpha, so we know that polonium, PO, 208, it emits alpha, 24, and becomes lead. So 84 minus 2, it will be how much? Exactly 82. And 208 minus 4, it will be 204, and that's how we get to what? The 3 marks. This is finished, but hold on. They didn't give us about the half-life and the count rate, but if they ask, okay, for example, triple I, if they ask about the half-life, what I'm going to say? I'm going to say that the activity with what? With time, right? I'm going to start the time now, okay? And the activity, okay, it was how much? 890. They didn't ask it, okay? And without the source, only this, okay, without the background radiation, okay, source only, which is what? 850. Why 850? I subtract the 40, the background radiation. So I keep dividing this value every half-life. This is first half-life, second half-life, okay, third half-life, etc. Okay, I keep dividing by what? I keep dividing by 2. So it will be 425, okay, 212.5, okay, and 106.25. Then what I will do, I will add the background radiation. I will add the 40. So it will be 465, okay, 252.5, okay, and here 140, I'm sorry, 146.25, etc. So I can know how much is what, how much is the life or how many half-lives happened, okay? So that's it. We finished the whole year. If you have any question, you can stay online. If you don't have a